Good morning, everybody. All right, we are back to SAT Khan Academy problems. We're solving SAT problems live every morning, Monday through Friday. And today we are tackling data inference problems. Once again, there's some issue with Google Hangouts and the camera. So we're going to jump right to the share screen. Can't see me this morning. All right, let's get into it. Here we go. So I got the first problem loaded up here. I haven't looked at it yet. I haven't looked at any of these problems. It's part of the fun, as always. Is this the right section? Yeah, data inferences. We're going to clear this. And without further ado, we are going to get started. And here we go. A random sample of 35 four-door passenger vehicles had a mean gas mileage in miles per gallon of 25.9 mpg, miles per gallon. The estimate had a margin of error, of 2.6 miles per gallon, 2.6 miles per gallon at 98% confidence level. Which of the following is the most plausible value for the true mean gas mileage of all four-door passenger vehicles? Okay. So let's see, 98%. So it's got a margin of error. This is interesting. So it's got a 2.6% swing, 98% confidence level. Now, I'll be honest with you, I'm not exactly sure how to approach this. Now, I see that it's at 25.9 miles per gallon. Usually when we say there's a margin of error of 2.6, that means it could swing either way. Like it could be 24.3 at one end, or it could be all the way up to 23.3, excuse me. Right, we subtract 2.6, we go down to 23.3. It could go up to 28.5. Go up here too. 98% confidence level. Which of the following is the most plausible? So, I mean, it could go either way. So my guess is I would knock these two guys out right now. Okay. And I mean, the 98%, I don't even know how this factors in, because this is kind of throwing me off. Like, hey, if it's 98% confidence, but it could swing either way equally drastically. 98%, 2.6. Gosh, how do I approach this? My guess, I'm feeling like it would probably be 29. This seems like it's closest to our original mean value, and it's the closest one within that margin of the 2.6, that 2.6 margin of error. And 24, oh, actually, no, I'm sorry, it's not closest. 24 is actually closest. So 24 is actually closer than 29, right? 24 is 1.9 away from the main one. It's within the 2.6 margin of error. 29 is beyond the margin of error, my bad. So I'm gonna say 24. I really want to read their explanation, because I'm curious to know how the 98% factors in. I actually don't know. So let's say 24. So what I would do on the test, I would just kind of analyze it, something like this, and see what it is. So it is right, but let's see what they say. It's literally what I did, but where's that 98% factored in? So it says this is very likely that the true mean is within the margin of error. That's all it means. Okay, so they're not even mathematically factoring it in. And then they do these two things like I did. You subtracted 2.6, added 2.6, and the mean is in between these two values, and 24 is the only one. So, okay, there you go. So my hunch was kind of right, but I wasn't totally sure, so that's interesting. All right, let's move on to question 2. Here we go. All right. Based on random samples of river heights, oceanographers estimate that 4,800 cubic kilometers of fresh water is discharged into the Arctic Ocean annually. The estimate has a margin of error of 240 kilometers cubed at the 90% confidence level. Which of the following is the most reasonable claim about the volume of freshwater discharged annually into the Arctic Ocean? It is between 4,800 and 5,040. No. So again, that margin of error can go plus or minus either way, right? So it's going to go down by 240 and up by 240. So down by 240 is 4,560. Up by 240 is 5,040. So this would be the range right here. If we're talking about margin of error. A is not good because the lower bound is wrong. B looks pretty good. C is wrong. Okay, that's not so bad. So again, the margin of error gives us that zone by adding and subtracting it from the mean. So we're pretty confident it is B. And we're good. All right. I mean, I'd almost say those percentages that they're giving are almost a red herring of sorts. They're not really even being used to calculate the numbers, which is really funny. And that actually threw me off, right, with the first problem. Okay, let's go here. Question number 3. A random sample of international flights in 2013 showed that 79% of the flights arrived within 15 minutes of their scheduled arrival time. And this estimate had a margin of error of 3% and a 95% confidence level. Again, I'm not even going to acknowledge the 95%. Which of the following conclusions is best? Exactly 79% arrive within 15 minutes of their scheduled time. Showed that a random sample. So I wouldn't say exactly. The problem is there's 2 problems. One, there's a margin of error. 2, it's just a sample that has a margin of error. So exactly is going a little too far. I'm going to take that off. Exactly 76% arrived. No, that's even worse because that's away from the mean. So that's no good. Between 76 and 82% arrive within 15 minutes. I'd say this is good because, again, we're taking that margin of error. We're subtracting it and adding it, right? We've got 79. We're subtracting 3. We got 76. We're adding 3. We got 82. And there's our zone. So I would say somewhere in here would be good. 92 and 98. 92 and 98. I wouldn't say that. So let's go with C. Okay. That is good to go. Let's go to number 4. We've got 2 left for the day. Let's take this out. And then I've got to get to the gym. It's early, very early in the morning here in LA. Question number 4. In a poll of 1,578 randomly selected American adults, 44.8% of the respondents said that airlines should allow in-flight calls on airplanes. The poll reported a margin of error of 2.5% at a 95% confidence level. Which of the following is most likely to be equal to the percentage of all American adults who would say that airlines allow us in-flight calls? Let's again break this down based on the margin of error. Gosh, I'm yawning up a storm. We subtract 2.5 is 42.3. And then we add 2.5. Whoops, or 2.3. We add 2.5 and it's 47.3. Like this, right? And let's say 43 is in that zone. Right? 40 is beyond it. 40 is less than that. 48 is a little too big. 95 is way too big. So we're going to go with B. Let's see if it is correct. And it is correct. Last one. Ladies and gentlemen. Last but not least. Here we go. Here we go. Question 5. A random sample of 35 four-door passenger vehicles had a mean gas mileage in miles per gallon of 25.9. The estimate had a margin of error of 2.6 miles per gallon at a 98% confidence level. All right, so we got to get on this 2.6. So look what I'm going to do once again, 25.9, and we've got as subtracting 2.6. That is 23.3. I'm doing this mentally, but you could definitely do this in a calculator because it is calculator section right there. But it's fine, I guess. 26.5, 28.5. Now check it out. Was the most plausible for the true mean? This is right in that zone. I'm going to go with 24, but let's check out 29. Too big. 32, too big. 35, too big. This is like, is this exactly the same as question 1? I literally think they've repeated question 1, question 5. Pretty sure. You can tell me, leave a comment if you agree. Let me know if that is true. I'm pretty positive this is the exact same. All right, good. Yeah, it's the exact same. All righty, so that's it, guys. Let's see if we can get myself back on camera here. I don't think it's working, but let's try it out. Stop the screen share. No, it's not working. So, all right. Thank you guys so much for joining again. If you have any questions or comments, please email me at huzaifa@scalarlearning.com. Make sure to like this video, subscribe if you want to see all the videos and all the up-to-date information on SAT prep and math education, all that good stuff. Subscribe. Thank you guys so much for joining, and I hope you have an awesome day. Take it easy.